Hello everybody, this is Jyoti Mayekar and I am teaching nuclear physics, and this is first lecture, and the topic is nuclei and their properties. There are different models of the nucleus like liquid drop model, shell model, collective model and cloudy crystal ball model. Here we are going to study Rutherfords model. In 1911, Rutherford, on the basis of scattering of alpha particles, suggested that the nucleus is a compact structure. The atom of any element consists of a central hard core called as nucleus, and the diameter of nucleus it is 10 raised to minus 14 meter, and this nucleus is surrounded by electrons which are orbiting around the nucleus. More than 99.9% of the entire mass and the positive charge is concentrated inside the nucleus. All the atomic nuclei are spherical or nearly spherical and are composed of the two elementary particles, namely protons and neutrons. So let's talk about proton. A proton is positively charged particle. Charge on proton, it is same as that of the charge on electron, and the magnitude is same. It is 1.6 into 10 raised to minus 19 coulomb, and hence the atom is electrically neutral. A proton has mass 1.67261 into 10 raised to minus 27 kg, or all the masses of all the elementary particles. Generally they are measured in terms of electron mass. So mass of electron, it is taken as a standard. So if we compare with the mass of electron, mass of proton, it is about 1836 times more. All nuclei are positively charged. Magnitude of electric charge, it is an integral multiple of proton charge. So if a nucleus has atomic number Z, charge of that nucleus, it will be Z into E. Now let's see neutron. It is neutral electrically, that is neutron doesn't carry any charge. Mass of neutron, it is 1.67492 into 10 raised to minus 27 kg, that is slightly greater than the mass of a proton. Now let's talk about nucleons. Protons and neutrons together in a nucleus are called nucleons. Thus, nucleus is tightly bound system of nucleons with a large potential energy. The protons and the neutrons, they are held together in a nucleus by a very strong short range mesonic field, and according to Yukawa, it is an attractive force, and this force it is also called as nuclear force. Let's talk about nuclear species. A species of nucleus of an atom X known as a nuclide and is symbolically represented as XZA. Now here Z represents the atomic number, which is nothing but same as that of the total number of protons in that atom. And A, it is atomic mass number, that is total number of protons and neutrons, or in other words you can say number of nucleons. So atomic mass number, basically it is sum of number of neutrons and number of protons. The nucleus is surrounded by Z electrons. So suppose take the example of lithium 3,7, where 3 is atomic number, which is equals to number of protons. So Z equals to 3 protons, and atomic mass number 7. 7 is number of nucleons. So N equals to A minus Z equals to 7 minus 3 equals to 4. That is 4 neutrons. So basically atomic mass number minus atomic number, it gives you number of neutrons. Now let's talk about scattering of alpha particles. Rutherford and his co-scientists showed that scattering of alpha particles experimentally. See, experimental arrangement. Here we have a radioactive source enclosed in some cavity, enclosed in a lead box. Then we have diaphragms D1, D2, and they are made to fall on gold foil. Okay, so let's see. The radioactive source emits alpha particles. They are passed through two diaphragms D1, D2, and these diaphragms are used to get a narrow beam of alpha particles. Now, this beam is incident on a thin gold foil. While passing through the gold foil, the alpha particles spread all over. This spreading out of alpha particles on passing through a thin layer of matter, this is what is called as scattering. Now, the scattered alpha particles in a particular direction are allowed to strike the screen S, and that screen, it is basically coated with zinc sulfide. Now, when these alpha particles, scattered alpha particles, they strike the screen, they produce fluorescence. A microscope M can be used to detect fluorescence, and this entire apparatus, it is enclosed in vacuum. This is what is all about experimental arrangement. Now, what were the observations? When they observed, they found that some alpha particles are scattered through large angles, some alpha particles are scattered through small angles, some alpha particles are even reversed back, and some alpha particles passed straight through the foil. So, what was the explanation for these observations? The positively charged alpha particle showed scattering due to extremely dense concentration of the positive charge at the center of the atom. This massive part of the atom must be concentrated in a very, very small volume at the center of the atom, which is called as nucleus. Rutherford assumed that both the nucleus and alpha particle, they behaved as a point charges, and as they behaved as point charges, they obeyed Coulomb's law. What was Rutherford's model? Rutherford believed that the positive charge cannot be distributed in the whole mass of atom. Electrons are distributed around the nucleus in the empty space of atom. This distribution over a sphere of radius comparable with the atomic radius. That is why some alpha particles pass through the empty space of atom without any deflection, as they do not go sufficiently close to nucleus. See, nucleus, it is positively charged. Alpha particles, they are also positively charged. So if alpha particles will go close to the nucleus, alpha particles will experience repulsive force. Yeah. Now, if some alpha particles approach the center of the atom, they experience increasingly very large Coulomb repulsion, and that results in a large angle of deflection. What were the drawbacks of Rutherford's model? Rutherford assumed that electrons can rotate around nucleus in any orbit of any radius. Therefore, they must emit radiation of all frequencies. But this was not observed experimentally. It was found that the atom of hydrogen emits spectral lines of fixed frequencies, but not all frequencies. So this is the main drawback of Rutherford's model. Thank you so much. Please like and subscribe.